Number 6 on the 2021 exam. This is the Maclaurin series, power series one. Okay, so the function g has derivatives of all orders for all real numbers. The Maclaurin series of g is given by this guy on its interval of convergence. State the conditions necessary to use the integral test to determine convergence of the series, summation as it goes from 0 to infinity, 1 over e to n. Use the integral test to show that this guy converges. What are the conditions for the integral test? Hopefully you remember this. I've said in other videos that you need to at least state the conditions, and here it is. It's asking for the conditions. So we need to have, if we change this to a function, is 1 over e to the x, let's say, which is the same thing as e to negative x, okay? The conditions are that e to negative x is positive, decreasing, and continuous, okay? I don't always say continuous, but it has to be for the integral to work, okay? Positive and decreasing is usually what I say. And it has to be on the interval 0 to some finite number to infinity. In this case, 0 to infinity works as well, because e to x there's no domain restriction, okay? And it is positive and decreasing and continuous on this interval, okay? So we do the improper integral from 0 to infinity, e to negative s dx, write it as a limit. This probably is important. We'll look at the scoring guidelines in a bit. Well, I'll go through them in a bit. Use, find the antiderivative, then use the fundamental theory of calculus. Take the limit, it's equal to 1. Since the integral converge, the series also converges by the integral test. All right, let's see the scoring guidelines. Positive, decreasing, continuous, that's 1 point. Okay. All 3 conditions need to be written for the whole entire point. No partial credit, okay? Improper integral is 1 point. Okay. And then so this is the second point, or this one right there. And the third point, you need to write this one and then evaluate to get 1, okay? That's the third point, and then yeah, I think that's pretty much, it's 3 points. It doesn't, I'm not going to read the whole thing to so this is the integral test in itself. I don't think you writing this will get you any points. It doesn't look like it actually. And technically this is a geometric series, but we can't use that here. We will get no points if we use the fact that it's a geometric series, okay? All right. Use a limit comparison test with this series to show that this series converges absolutely. What does absolute convergence mean? That means the absolute valued version of this converges. If that absolute valued version converges, then this one with the changing sign also converges as well. Okay? That's absolute convergence. So, what's the absolute valued version of this? That's just without the changing sign right there. Okay? And now we do the limit comparison test with this. Okay? Using 1 over e to the n. Okay, so we write it like this. We can do L'Hopital's rule. And the limit is half, which is finite and positive. Okay, I wrote it like that. I don't know if you need to write that. We'll see the scoring guidelines in a bit. Since this guy converges, this guy also converges as well by the limit comparison test. And that means this guy converges absolutely, since we showed up here, the slide. Okay, let's look at scoring guidelines. So that's a limit comparison test. I did it with the absolute valued version directly. First point is earned for setting up the limit comparison test with or without absolute values. Limit notation is required, okay, so I got 1 point there. Okay. Second point is explanation. Second point cannot be earned without the use of absolute value symbols, which occur. Earning the second point requires correctly evaluating the limit, which we did, half, okay? Knowing the limit is positive, and noting that the limit is a positive number. Technically, I wrote that there. Okay? The response does not have to repeat that guy converges, but we did. A response that draws a conclusion based on, without reference to a series, does not earn the second point. Oh, so we did say series, not sequence, okay? If the response does not explicitly use the limit comparison test, then no points are earned in this part. So do we have to say limit comparison test? Let's add it in. Let's just be careful. By limit comparison test. I don't know if we actually need that. from how I'm interpreting the scoring guidelines, seems like we need it. Although we did the steps for limit comparison test there. Okay. Response must specify that this guy converges absolutely, which we did. Okay. So you can read the scoring guidelines in more detail, but the key points I'll point out are you have to somehow say this, the absolute value version. If I do the limit comparison test, get half, say it's finite and positive. I wrote it like this. You should just write it in words. It's probably more clear than doing it like this, like how I did. So don't do as I did there per se. All right. I would accept it if I were a grader, but I don't know how they score it exactly. And then you have to write the conclusion that it converged. Absolutely converges. Okay. Okay, determine the Maclaurin radius of convergence for the Maclaurin series G. We go through the motions of the ratio test to find radius of convergence. So a sub n plus 1 divided by a sub n. Okay. Properties of exponents. This reduces down to x. Does not depend on n. Pull it out in front. Don't forget, you can't drop the absolute values. Here, I can rewrite e to the n plus 1 as e times e to the n. Okay. I wrote it like that. And then I did L'Hopital's rule. Those would cancel. So we're left with 1 over e. Okay, so we set this less than 1, and we get the absolute value x less than e, so the radius is e. Okay, let's see the scoring guidelines. Sets of ratio is 1 point. Computes limit of ratio is another point. And then answer r equals e is 1 point. Okay, we got all the points. Okay, part D. First two terms of the series are used to approximate g of 1. Use the alternating series error bound to determine an upper bound on the error of the approximation. This one is pretty simple. If we just remember that the maximum error is the first omitted term. We're summing two terms. The first omitted term is the third term, n equals 3. That's the maximum error. So error is less than or equal to n equals 3. Just get rid of that changing sign because it's absolute value. Okay, so 1 over 2e cubed plus 3. And that's the answer. 1 point. Okay, that's it. So the problem itself was not difficult per se, but I would carefully look over the scoring guidelines one more time and see what's important to write down and what you must write down, I should say, in order to get the points that you need, that you want. All right. I tried pointing out here, but the scoring guidelines, at least for the more recent years, there's lots of text. So go read what's required, what's possible, what's accepted, what's not. So I would, these are all public information posted on the College Board website. So I would go look at those to really find out what you need to write on the exam. All right. That's it for this video. Hopefully it was helpful. Please give this video a like if it was, and hopefully I'll see you in another video as well. Bye.